Hi students, once again I welcome you all to my channel Abrar Sir Classes. Today we'll be seeing some interesting problems on the topic resonance. This is the first problem. It is saying in given LCR circuit, the voltage across the terminals of a resistance and current will be. Here they have given R is equal to 50 ohm and voltage across the inductor is they have given 400 volts and voltage across the capacitor they have given 400 volts. Okay. Now these two voltages are equal. VL is equal to what? VC. This circuit is in resonance. Okay. This circuit is in resonance. Therefore, what happens when the circuit is in resonance? What is the formula for Vn? We have seen in the previous classes. Square root of what? VR square plus of, let us say, VL minus VC. Okay, in general, if VL is greater than VC. Both are equal here. Therefore, what happens? Okay, this gets cancelled. Vn is equal to what? Square root of VR square. That is root and square gets cancelled. Vn is equal to VR. Okay, V net is equal to VR. How much they have given? V net. This is V net. Okay, V net they have given 100 volts. Okay, that is equal to 100 volts. What exactly you are supposed to calculate? You are supposed to calculate the voltage across the terminals of resistance. Okay, the voltage across the terminals of resistance is 100 volts is the right answer. This is existing here and here. Okay, now you have to calculate the current also. What is current is given by, we know that VR is equal to what? I into R. From here you can calculate the value of the current. I is equal to VR by R. Okay, that is equal to 100 by 50. 100 by 50 is equal to how many amperes? 2 amperes. 2 amperes is the right answer. 100 volts, 2 amperes, this is the right answer. Okay, 100 volts, 2 amperes is the right answer. Let us see the next problem. It is saying a series RLC, R is equal to 10 ohm, XL, XC. See here, XL is equal to XC. The circuit is in what? The circuit is in resonance. Is in resonance. Is supplied by V is equal to 10 sin of omega t volt. Then power dissipated in the circuit. Okay, power dissipated will be what? Power dissipated is equal to what? I square RMS into R. R we have seen V RMS by Z, the whole square. Okay, this is Z. Okay, into R. Now let us calculate the value of the power dissipated. Okay, now to calculate the value of the power dissipated, what exactly you are supposed to calculate? You have to calculate Z. How Z will be? In case of resonance, Z will be equal to, we noted Z is equal to what? Square root of R square plus of XL minus of XC. Let us say if XL is greater than XC. What happens here? Since XL is equal to XC, this gets cancelled. Z is equal to square root of what? R square. Z will be equal to R. That is equal to how much they have given? 10 ohm. 10 ohm they have given. Okay. Now, what is VRMS value? Z we got. Okay. Z is equal to R is equal to 10 ohm. What is VRMS equal to? Compare this. V is equal to what? 10 sine of omega t. Right. 10 sine of omega t. From here we can calculate V is equal to what? Compare this with equation. In general, V is equal to V naught sine of omega t. Okay, where V naught is how much? 10 volts they have given. How to calculate VRMS? VRMS is equal to what? V naught by root 2. V naught by root 2. That is 10 by root 2. Now substitute here. How much is VRMS? 10 by root 2. Okay, 10 by root 2. And how much is Z? Z is equal to nothing but 10 only. Okay, 10 the whole square into R. R is how much? 10. Okay, that is equal to this 10 gets cancelled. 1 by root 2 is square. Okay, 1 by 2 into 10 is equal to 5 watts is the right answer. Power dissipated is how much? 5 watts. Hope you understood this. This is a very easy sum. Now let us do the next sum. Now, in a given circuit, the reading of voltmeter V1 and V2. How much is V1? Where is V1? V1 is here and V2 is here. Okay, they have given VL. Okay, is equal to that. V1 is equal to how much? 300 volts. That is voltage across the capacitor. Okay, VC is equal to what? V2 is equal to how many volts? 300 volts. Right. Okay. Now see here, VL is equal to VC. The circuit is in resonance. The circuit is in resonance. The circuit is in resonance. So what happens when the circuit is in resonance? Okay, what exactly the reading of voltmeter V3? Where is V3? V3 they are asking. Okay, V3 is equal to question mark they are asking, and then and the value of the current that is flowing in the ammeter. Okay, the value of the current flowing in the ammeter. We know that. Okay, how much is the current? I is equal to how much? And here they what they are asking V3 is equal to question mark. Okay, V3 is equal to question mark. How to proceed with this sum? We know that when the circuit is in resonance, what happens? The net voltage, okay, will be equal to what? VR. Okay, that is equal to VR. That is equal to how much? That is equal to VR is equal to what? I into R. That is equal to how much? They have given VR is how much? We don't know. That will be equal to what? Vn. How much is Vn? We know. Okay, Vn is equal to how much? 220 volts. Vn is equal to what? VR. Okay, voltage across the resistor is equal to how many volts? 220 volts. Right. Okay. Therefore, here I can write VR is equal to I into R. Okay. That is how much is VR? VR is nothing but 220. That is equal to I, we do not know, into R is how much? 100 ohm. Right. Okay. That is I is equal to 220 by 100. 0 gets cancelled. 22 by 100 is 2.2 amperes. 2.2 amperes. Therefore, from here I is equal to what? 2.2 amperes. 2.2 amperes. And what is the voltage across the resistor? That is equal to what? V3. Okay, they have given this is V3. Okay, that is voltage across the resistor. Voltage across the resistor they have given VR is equal to what? VR is equal to this, V3 is equal to, okay, you have to calculate. Okay, now here this is V3 is equal to how many volts? 220 volts. And how much is the current? 2.2. Hope you understood this. This is very easy. Okay, here VL was given, VC was given, VR, that is V3, was not given. Here we have calculated. Okay, just now after calculation we got voltage across the resistor V3 is equal to 220 volt. This is 220 volt, that is V3, 220 volts. And how much is the value of the current here? The current is how much? I is equal to 2.2 amperes. Hope you have understood this. Very easy sum. Okay, let us proceed for the next problem. Now here what is saying, here what is given? R is given. Okay, the figure shows a LCR network connected to 300 volts. Okay, net voltage is how much they have given? Net voltage is equal to 300 volts is given. Now the circuit elements are R is equal to what? XL is equal to what? XC is equal to how much? 10 ohm. Okay, XL is equal to XC. The circuit is in resonance. The circuit is in resonance. Okay, V1, V2 or 3 AC voltmeters connected as shown in the figure, which is following represents the correct set of readings. See, when V net is equal to what? When V net is equal to 300 volts. Okay, 200 volts. What happens to this one? When the circuit is in resonance, Vn is equal to Vr. That is equal to how much? 300 volts only. Vn is equal to what? Vr, that is equal to 300. Voltage across the resistor is how much? 300 volts. Right. The figure shows. Okay. Now the circuit elements are certain. Now here, since they have the same value, okay, R is equal to X is equal to, what will be the value of the voltage across the inductor and the voltage across the capacitor? That will be also same. V2 will be equal to how much? V2 will be equal to V3 is equal to how much? That will be again that will be equal to 300 volts only. 300. Okay, 300 volts only. Okay, V1 that is V1 is equal to voltage across the resistor, that is 300 volts. How much will be the value of V2 and V3? That is also equal to 300 volts, because they have been given what? R is equal to XL is equal to, since the resistance is same, voltage will also be same, but the circuit is in resonance because XL is equal to XC. Hope you understood this one. Okay. Now let us see the last problem. What they are asking here in the circuit shown in figure, neglecting source resistance. Okay, source resistance neglect. Okay, the voltmeter and ammeter readings. What exactly you are supposed to calculate? See here, XL is equal to XC. XL is equal to XC. The circuit is in what? The circuit is in a resonance. Is in a resonance. Okay. What you are supposed to calculate? You are supposed to calculate the reading of this voltmeter and the reading of this ammeter. Okay, you have to calculate the reading of this ammeter. Now, when the circuit is in resonance, what happens? When the circuit is in resonance, V net, how much they are given? V net will be equal to what? V net will be equal to VR. VR is where? VR is here. Voltage across the resistor. Okay, VR will be equal to how much? 240. Right. So what is VR is equal to I into R. VR is equal to I into R. VR you know 240 is equal to I. You do not know into R you know. R is how much? 30 ohm. I is equal to 240 by 30 is 8 amperes. Okay, 8 amperes. Now what will be the, okay, I is equal to 8 amperes. The reading of this one, this ammeter is how much? 8 amperes. But what will be the reading of this voltmeter here? Okay, see XL and XC. XL will be what? Leading. The voltage across here, okay, VL will be what? Leading, and this will be what? Lagging. Okay, VC will be what? Lagging. What will be the reading of this voltmeter? Okay, the reading of this voltmeter will be, okay, the reading of this voltmeter will be V is equal to VL minus of VC. VL minus of VC. Okay, since the circuit is in resonance, okay, these two, this voltages will be what? At an angle of 180 degree. Okay, now if this is, if I draw the phasor of voltages, this is 0, this is I, this is what? VR, this is what? This will be VL. Okay, and this will be what? VC. VC. Okay. These two are equal. Okay, and they are at an angle of what? 180 degree. This is in the positive y-axis. This is in the negative y-axis. VL minus VC. Okay. So what will be the reading? Reading of this voltmeter will be 0 volts. 0 volts. Okay. Now where is 0 volts and 8 amperes? Yeah, 0 volts and 8 amperes. Hope you understood this. You might have enjoyed these problems. If you have liked this video, kindly share with your friends. Ask doubts in the comment box. Subscribe for my channel, and do not forget to ask doubts in the comment box. I wish you all the best for your KCET and NEET examinations. Kindly like the video if you are really liked it.